Hi friends, here we are given three functions. We have to find out whose graph among them is symmetrical about the origin. What does it mean, symmetrical about the origin? It means the function is an odd function. Even function, the graph is symmetric about y-axis. Odd function, the graph is symmetric about origin. What does that mean? If if 2 comma 3 are part of the graph, that means minus 2 minus 3 are also part of the graph. If 4 comma 7 are part of the graph, that means minus 4 minus 7. So it is symmetric about the origin. What does that mean? Okay, whatever xy are there on the graph, minus x minus y are also there on the graph. f of x, f of minus x is equal to minus of f of x. Okay, when you take minus x, the result should be minus of f of x. So y equal to x. So whatever y that we get should become minus y. Okay. So that is symmetric about origin. Now here in this case, 3 power x plus 3 power minus x. If you replace, this is f of x. Okay. What is f of minus x? F of minus x is 3 power minus x plus 3 power minus of minus x, which is nothing but 3 power minus x plus 3 power plus x, which is the original case also. 3 power x and 3 power minus x. F of x is equal to f of minus x. That means it is even. That means it is symmetric about the y-axis. Whatever x, the value that we are getting, minus x also, we are getting the same value. So it is symmetric about y-axis. It is not symmetric about origin. Symmetric about origin means whatever this value that we are getting, here also we should get the same thing. The graph should look uh, something like a sine, something like this. Like we have sine curve, right? This point is there, this point is also there. This point is there, this point is also there. Likewise, the graph is symmetric about the origin. What does that mean? If you flip it by 180 degrees, you should get the same curve. For example, sine curve, if you flip it 180 degrees, you will get the same curve. Tan curve, tan also. If you flip it 180 degrees, you will get the same curve. If you flip your notebook or the paper on which this graph is drawn, if you flip it 180 degrees, rotate the paper 180 degrees, you will still get the same graph. So the first one is clearly an even function. Okay. Now second case, cos is even, that we already know. And log of x plus under root 1 plus x squared, x, this is an odd function. Why? Let us assume f of x equal to log x plus under root 1 plus x squared. Then what will be f of minus x? It will be log minus x plus under root 1 plus minus x whole square, which is again x square only. Okay. Now let us notice this thing. 1 plus x square under root plus x into under root 1 plus x square minus x. This is in the form of a plus b and a minus b. The product is a square minus b square. That is 1 plus x whole square, root of 1 plus x square, which will become the square of this will become 1 plus x square minus x into x. This is x square. This is equal to 1. What does that mean? Minus of x plus minus minus x plus 1 under root 1 plus x square is equal to, we can write this as 1 by x plus under root 1 plus x square. See, the product of this and this is equal to 1. The product of this and this is equal to 1. That means this is 1 by this thing, which is nothing but log of x plus under root 1 plus x square whole power minus 1. Right. This is nothing but minus log x plus under root 1 plus x square, which is nothing but minus f of x. Okay. If f of x is this, minus log this thing x plus under root 1 plus x square is minus f of x. Right. So this function log of this thing is actually odd function. Right. Now g of f of x, if you take, if f of x is odd, that means let's try g of f of minus x. G of f of minus x. F of x is odd, that means g of minus of f of x. And G is even. That means G of minus f of x will be equal to G of f of x. So net, this entire function is even because cos of this thing and cos of minus this thing both should be equal to, both are same, right? Because cos is even. Cos of this one versus cos of minus this one both are same. So this is an even function. So this is also gone. Now let us take the third case. We want an odd function, right? F of x plus y is equal to f of x plus f of y. Okay. Now here let's do one thing. Here let us substitute y. Let us take y equal to minus x. What does that mean? F of x plus minus x, that is f of x minus x, should be equal to f of x plus f of minus x. Okay, that means f of 0 is equal to, f of 0 is equal to f of x plus f of minus x. Okay, let us keep it like this. Now, instead of y equal to minus x, let's keep y equal to 0. What does that mean? F of x plus 0, that is f of x, is equal to f of x plus f of 0. Okay, what does that mean? F of 0 is actually equal to 0. Okay, because f of x is equal to f of x plus f of 0. Right, this equal to this plus something else. Obviously, that means f of 0 should be equal to 0. What does that mean? 0 equals f of x plus f of minus x. F of minus x. What does that mean? F of minus x, if you bring it to this side, f of minus x is equal to minus of f of x. Okay, very simple. So that means this is actually odd. Okay, we are given a slightly lengthy proof, big proof, but essentially f of x plus y equal to f of x plus f of y. We can directly say that it is an odd function. So for example, if f of x is something like 2x, f of x equal to 2x or something, then f of x plus y, then it will become 2 into x plus y, which is nothing but 2x plus 2y, which is nothing but f of x plus f of y. Right. F of x is 2x, then f of x plus y x plus y is 2 into x plus y, which is nothing but f of x plus f of y. So basically, a function something like this. It's a straight line function. Straight line function, and it is passing through the origin. Obviously, this is an odd function, right, guys? Whatever point that is there here, the point is there here also. Right, yes. So the third one is only odd function. That means only the third one is symmetric about the origin. Rest two are even functions, which means they are symmetric about y-axis. Right, guys. Thank you.